definition. A function f is said to be continuous at a point x equal a, where this has to be a member of the domain of f. If for any positive number, I call it epsilon, given, there exists another positive number, I call it delta, that depends on both epsilon and the point A, such that absolute value, anytime absolute value of x minus a is less than delta. So this is what I mean by the delta here. Good. So this implies that absolute value of f at x minus f at a is less than epsilon. This is another an equivalent definition to the one we already have. So for those of you who are mass major students, this definition should never depart from your lips. In fact, as you grow, maybe in second year, it is an interesting exercise to prove in analysis that this definition is equivalent to the previous one we have. That is conditions 1, 2, and 3. You know, so it's an interesting exercise to see that the two are equivalent. But since at this level we have people of different disciplines that may not really need this epsilon definition, epsilon delta definition, we'll keep to the three conditions we listed. But for the mass major, please bear at the back of your mind that this is what we shall be worrying about anytime we hear about continuity of functions. Because we shall be proving rigorously that a given function f is continuous not just by checking conditions 1, 2, and 3, but for the engineers, the physicists, and then all of that people around, it is sufficient to give them those three definitions, conditions. And we work with that, and then we use it to learn continuity. But as we progress in the field of mathematical analysis, we shall be dealing with this more in details and more thoroughly. Okay, so we leave it at this for now, and then we'll take a look at some other concepts. You know, left-hand continuity, right-hand continuity, and then probably continuity at an interval. After which we list some properties of continuous functions. You know, with that we shall have cleaned up all we need to know about continuity of functions. All right. Okay, we want to define what we mean by left-hand continuity. A function f is said to be continuous from the left-hand side, or just simply from the left, if the limit of f at x is said to be continuous from the left at the point A, if the limit of f of x as x tends to a from the negative is equal to the point f at a. Again, f is said to be continuous from the right at a if the limit of f of x as x approaches a from the positive is equal to f at a. So any function that behaves like this is said to be continuous from the left if this is true. It is continuous from the right if this is true. Okay. We shall see some examples very shortly, but before that, let me finish up with these definitions. A function F is said to be continuous on an interval. Let me call that interval I. If it is continuous at every element, let me call it A of the interval. So if our function is continuous at every element of the interval, I will say it is continuous on the whole of that interval. So if f is continuous at every element of the set of the interval I, we say it is continuous on the whole of the interval. But if there exists a point for which it is not continuous, then we say it is not continuous at that point. At that point. So we can now see that continuity is actually a point based, and in fact it is a local property. I'll show you very shortly, graphically, what I mean by saying it is a local property. So that's the next thing we'll see.